Hello, this is Jagan, a computer science student at Bennett University. I'll be explaining our HPC project reducing inference latency of large-scale image captioning in Telugu by our team. Image captioning has been around for some time, that is giving human-like captions for any image using deep learning techniques. It certainly requires a dataset like Flickr 8K which was used in training our model. All the works that exist are mostly for English, and so we made a captioning model for Telugu. But a model is not just enough for practical uses, we need to make a model faster. It was not possible to speed up testing for single image as the prediction follows a greedy algorithm which is serial in nature. Hence our objective was to use CPU scheduling libraries to make it faster for multiple predictions. We must study the behavior of different libraries with our model by varying the CPU cores. This study was done using 4 libraries, namely Python's native multiprocessing library, PyMP, JobLib, and Ray, by varying the CPU cores. Let's have a look at our code. I have Jupyter up and running. I'll start with the base model code. Here we have all the imports, all the paths defined, and global functions for general use case like loading up a file and loading the train and test images, and here a pre-processed image function for extracting for extracting features of an image. We have a class for the model, and it has all the variables and initializations, a method for the greedy algorithm, and a predict function a predict method which gives the extracted features of an image to the greedy function for obtaining a caption. We can see the serial implementation with a for loop define and run for train and test images. And this is the Python's native multiprocessing library. Here we use a pool.map function for parallel scheduling. We use the generalized function for different cores, and finally plot the data. Following the same structure, we have PyMP, which uses parallel function defined here to convert serial code to parallel without changing much of the syntax. And similarly JobLib and Ray, following the syntax as per their respective documentations. Finally, we have all the data in the cell plotted for a much better understanding. Now we have done some simple calculations on these values to get a broader view on the performance and trends of each library. In this spreadsheet, we see some tables, and I'll explain each and every one of them. The first table has all the data which has been observed from the code, and the second table ranks these libraries according to their performance in each step. Now here, the third table is a speed up calculation with respect to the serial code. We see that on average we get a 3.1 times speed up with any library, and individually PyMP gives the best speed up, followed by JobLib, multiprocessing, and Ray. Now these can also be observed in the second table, where here we see that PyMP is almost always the fastest library and Ray is almost always the slow. JobLib takes the second position with most of the time coming up faster, and the third position with multiprocessing. Fourth table gives us a speed up of every library with each additional core added. We see that the physical cores on average give us a 1.2 times boost, whereas the logical cores give little to no improvement at all. Summarizing all the observations, we have seen a plot comparing the libraries. The speedups achieved as calculated and seen in the spreadsheet. In conclusion, we saw that all the libraries performed far better than the serial implementation, and PyMP being the best surpassed Python's native library. Also, logical cores had no effect, whereas the physical cores showed good improvement. Additionally, other approaches with much divided functions having more parallel scheduling could have resulted in the usage of logical cores. Dask was such library which could have helped. Ray was the slowest since it had more functionalities and some additional background tasks which slowed it down. These are the references for our project. That's it. Thank you for watching the video. Have a great day.